Introduction to Indexing Techniques in DBMS. What is indexing in DBMS? Indexing in DBMS is a technique to improve the speed of data retrieval. Just like an index in a book helps you quickly find topics. A database index helps the system locate rows without scanning the entire table. It is essential for optimizing large databases. Why is indexing important? Imagine searching a book without an index, you had flip every page. That is how a database performs without indexes. Indexes reduce query time significantly by allowing direct access to the needed data, especially in large scale databases with millions of rows. How indexing works. An index is created on one or more columns of a table. It creates a separate data structure like a sorted list or a tree that maps key values to row locations. When you run a query, the database uses this structure to jump directly to the desired row. Types of indexes: single level index, multi level index, clustered index, non clustered index, primary and secondary indexes, bitmap index. We will now go over each of these types. Single level index. A single level index has a single data structure, typically a sorted file, that holds index entries. It is simple but not efficient for large data sets as it still requiring scanning the index linearly. Multi-level index. Multi-level indexing breaks the index into levels, where the top level index points to lower level index blocks, and so on, until the data. This reduces the number of I/O operations needed, similar to a binary search tree. Clustered index. A clustered index sorts the actual data rows in the table based on an index key. There can be only one clustered index per table. It is efficient for range queries and queries that sort by the column. Non-clustered index. A non-clustered index stores pointers to the actual data rows. The table's data remains unsorted. You can have multiple non-clustered indexes and they are useful for fast lookups when the data doesn't need to be physically stored. Primary versus secondary index. Primary index created automatically on the primary key column. Secondary index created manually on non primary key columns. These indexes support fast access to rows through different fields. Bitmap index. A bitmap index uses a bitmap array of bits for each distinct value in a column. It is useful in data warehouses and queries with many and or conditions on categorical data. Indexing in B plus tree. B plus tree is the most widely used indexing structure. It keeps data sorted and allows fast insertions, deletions, and lookups. All actual data pointers are stored at the leaf level, and the internal nodes guide the search. Advantages of indexing: faster data retrieval, efficient use of system resources, helps enforce uniqueness with primary keys, speeds up order by and group by operations. Disadvantages of indexing: slower insets and updates due to index maintenance, extra disk space required, poorly chosen indexes can degrade performance. When to use indexes? Use indexes when tables are large. Queries use where, join, order by, group by. Avoid indexing columns that change frequently or have many duplicate values. Real world examples. In an employee database, indexing The employee ID column allows HR system to quickly fetch details without scanning the entire employee table. Indexing versus searching. Without indexing, searching is done using a full table scan, checking row by row. Indexing allows log n search time instead of linear, especially in sorted or tree based indexes. Composite index. A composite index is built on multiple columns. Example, indexing both last name and first name. It helps when queries filter on more than one column together. Covering index. A covering index contains all the columns a query needs. So the database doesn't have to fetch the full row. This leads to faster execution, especially in read heavy applications. Index maintenance. Indexes must be updated when data changes. Too many indexes can slow down insert, update, and delete operations. It is important to review and optimize index using regularly. Index design best practices. Index columns used in where and join. Avoid indexing small tables. Don't over index. Monitor query performance with tools like explain plain. Summary. Indexing is a vital optimization technique in DBMS. It makes queries faster, improves performance, and supports large scale applications. Understanding index types and when to use them is key to building efficient databases. Quiz and recap. What is the difference between clustered and non clustered indexes? When would you use a bitmap index? What is the structure used in B plus tree indexing?